Now we are going to see what is logarithmic function. Okay. Logarithm of a number to the given base is an exponent that must be raised to the base such that in order to produce that number. For example, the logarithmic function is y is equal to log of a number x to the given a such that a is greater than 0, x is greater than 0 and x is not equal to a is not equal to 1. Okay. Logarithm of a number is an exponent that must be raised to the base such that in order to produce that number is a logarithmic function. Its domain is x belongs to 0 to infinity and range is minus infinity to infinity. You will ask me why a is not equal to 1, why base of logarithm is not equal to 1. So a is not equal to 1. Okay. Basically logarithm is a inverse of exponential function. So if this is the logarithmic function, what will be its exponential function? Its exponential function will be a to the power y is equal to x. Its logarithm, इसका inverse क्या होगा? What will be the inverse of this function? Inverse of this function will be log x to the base a is equal to y. If we take base as a 1, then our exponential function will become x to the power a to the power y is equal to a to the power x and 1 to the power x if we take base as 1 and x belongs to r. So what will this function will become when 1 to the power x and x belongs to r? Then our function y will become 1 and this is a constant function. And this constant function is non-invertible. What is invertible and non-invertible? You will know about invertible and non-invertible in upcoming classes when we are going to learn about function chapter. Okay. So remember that y is now just remember y is equal to 1 is a constant function and it is non-invertible. So when non-invertible means this function y is equal to 1 doesn't have inverse. Non-invertible means inverse can't exist. In order to become a function, in order to exist a inverse of a function, then that function must be invertible. Invertible means that function must be 1 1 and on 2. This is a constant function. So this is a constant function and it is non-invertible, hence inverse can exist, hence base cannot become 1, a cannot become 1. You will ask me, sir, what is the solution of log 1 to the base 1? This is you can say that any number can be, any x belongs to r will give the solution to this or this x belongs to r will be the value of this log 1 to the base 1. And also with base 1 we cannot determine unique logarithm, hence base cannot become 1, and it is also not and base cannot become 1, cannot become 0 and cannot be negative, because negative to the power x, sometimes it is even, sometimes it is odd and sometimes it is not whole number. We cannot define for x, we cannot define for a is equal to 1, a is 0 and a is less than 0. Now we are going to see the graphs of logarithm. To see the graph of logarithm, we are taking two cases. First case is a is greater than 1 for x belongs to 0 to infinity. So I split this range into two parts. X belongs to 0 to close 1, x belongs to close 1 to infinity. So this is x, this is y, this is negative infinity, this is positive infinity, this is positive infinity, this is negative infinity. For a is greater than 1 and x belongs to 0 to 1, what will be the y? When x, for example, x is 0 and a is greater than 1, a is 2, what will be the power we should raise to 2 such that we will get 0? It will be negative infinity. And when x is equal to 1, it will be, value of the y will be 0. So negative for x belongs to 0 to 1, our y will be minus infinity to 0. Minus infinity to 0. So graph will be like that. And for 1 to infinity, when x is 1, then y will be 0, and when x is infinity, for a is greater than 1, y also will be the infinity. So now onwards, this graph will be like that. This is the graph for a is greater than 1, x belongs to 0 to infinity. Okay, now second case. For a is greater than 0, a is less than 1, and x belongs to 0 to infinity. Let's take two cases. X belongs to 0 to close 1, x belongs to close 1 to infinity. Take this graph as, now we are going to draw the graph. This is x, this is y, this is positive infinity, this is negative infinity, this is negative infinity, this is positive infinity. Okay, for x belongs to 0 and a is between 0 and 1, let's say a is 0.1 and x is 0.000001. And our function is y is equal to log a log x to the base a. For x is 0.1 and for a is 0.1 and x is 0.001, what will be the value of y? The value of y will be positive infinity, because x is tending to 0. So 0.1 to the power infinity will tend to 0 when x will tend to 0 for what? Infinity. So for 0 and for 1, it will be 0. So for this is 1, so for x is 0.001, x is 0.001, we will get y infinity, like that. And for x is 1, we will get y 0. And for x is 1 to infinity, for 1 y will be 0. For positive infinity, x is positive infinity. Let's say 1, 2, 3, 9, 4, 6, 8, something. And x is between 0.1 and a is 0.1 and x is 1, 2, 3, 4, 9 for something, a large value, a positive infinity. For what value of, then y, what will be the value of y? It will be, it must be negative infinity, because 1 upon 0.1 to the power infinity, 0.1 to the power infinity will close to 0. 1 upon close to 0 will be close to infinity. So this graph will be like that. So these are the graph of logarithmic functions. Thank you.